Vogel's approximation method or penalty method is a preferred method over earlier method due to its solution being either optimal or very near to optimal. This method yields an initial basic feasible solution which may reduce the time for optimal calculations. The various steps involved in this method is explained in the attached PDF. Kindly go through it before attending this lecture. The Vogel's approximation method is also known as penalty method because the cost differences that it uses are nothing but the penalties of not using the least cost route. Under this method, computation takes too much time and hence it is slow, but due to its advantages, that is, very near optimal solutions, it has been widely used. Now let's understand Vogel's approximation method with an illustrative example, same as before. Vogel's approximations method approach is via finding penalty, which is eventually the difference between two least cost cells in each row and each column. Consider each row of the cost matrix individually and find the difference between two least cost cells. After we wrote them down in the new column and row, namely P1, we will find out the maximum loss in the system. Now this penalty is indicating loss due to the transportation system. So the maximum penalty column or row would be allocated first. Now allocation will be made in the cell in which cost is minimum. So we will make an allocation of 12 here. So 7 will be remaining in the supply corresponding to the row in which allocation of 12 is made. So the corresponding column in which allocation has been made sufficed the demand value completely. So this column is removed from the system. Now again, we have to calculate the penalty for every row and every column because now the matrix has been changed. This we will name as P2. We will make necessary allocations as per the procedure and will calculate two more penalty, namely P3 and P4, and repeat the same process of allocation. So we have our final allocation as you can see here. Now, the cost can be calculated with the same method as we have previously used for northwest corner method. The cost would be in this case 11 into 13 plus 10 into 18 plus 3 into 23 plus 6 into 32 plus 12 into 18 plus 1 into 41. Here 11, 10, 3, 6, 12 and 1 are the allocations that we have made. And finally the optimal cost is coming as 841 denomination. As compared with what we have got from northwest corner method, the cost obtained from VAM or Vogel's approximation method is more optimum as you can see here.